Hello, this is Machine Learning lecture number 1. Machine learning is already everywhere, so it is a topic that you should know something about. For example, if you type in a search query on the web, how that query is interpreted, how the websites that you're looking for are interpreted, and how the match between the two is made, all of this is run by machine learning algorithms. If you look at movie recommendations provided to you, they are provided to you by machine learning algorithms exploiting your previous experience with the site. Going a step further, automated assistants like Amazon Alexa, Google Assistant, or Siri, they all run on top of machine learning algorithms. Machine learning is used to interpret speeds to natural language, how the natural language itself is interpreted, how it's mapped to content that you're looking for or the commands that you are interested in executing. Machine learning is regularly used for image analysis. For example, in a self-driving vehicle, the unfolding scene coming from camera input is interpreted by machine learning algorithms. Machine learning has also achieved several benchmark tests, for example, surpassing human-level performance in game playing, such as Game of Go recently. Machine learning is being adopted by different disciplines, for example, biology, chemistry, physics, and so on. So it is everywhere, and we need to understand what it is and how to make use of it. So let's start by defining exactly what machine learning is. As a discipline, it aims to design, understand, and apply computer programs that really learn from experience. Okay? There are many ways to learn, or many reasons to learn. You can try to model, understand how things work. You can try to predict about, say, future outcomes, or try to control towards a desired output configuration. We will start by focusing on prediction as a core machine learning task. So let's take a few examples to understand what this actually is. You can make predictions about future events. So for example, you may have a market value of a stock measured as a function of time, and you see some historical behavior of that stock, and you wish to predict what happens the next day. In a similar vein, you can, in a self-driving vehicle, you can try to predict whether a collision is about to happen. In a medical context, you might predict the risk of acquiring or getting a recurrence for a disease, and so on. There are many problems that machine learning algorithms can help you to predict about future events. Now, there are other types of predictions that you can make, not only about events that are about to occur, but about properties you do not yet know. For example, I can take a movie and ask whether you would like this movie. That is a prediction of a property of a movie, whether you like it or not, that I can learn to predict. I can ask about molecules, whether a molecule here is soluble in water or other substance. It is a property that I can learn to predict. I can learn to predict properties about images. What is the content in the image? A category that should be associated with the image, that it's about mushrooms. In a more structured way, I can also turn machine translation into this form. I can take a sentence in English and ask, what is the corresponding sentence in Spanish?